It's hard to go a day without coming across some sort of foam insulation. It is found virtually everywhere in our modern world and is used in a wide variety of applications, such as construction panels, supermarket displays, vending machines, refrigerators, and packaging. Insulation foams are made by mixing highly insulating gases with polymers to form a closed-cell matrix, which traps the insulating gases inside. In the 1920s, the French-American company DuPont developed the miracle gases CFCs. Non-flammable, non-toxic, and with remarkable thermal insulation properties, these gases appeared to be ideal for use in insulation foams. However, in the late 1970s, a massive hole was discovered in the ozone layer, which was later connected to released CFCs destroying ozone molecules. The international community was quick to react by signing the Montreal Protocol in 1987, which began the phase-out of their use. Manufacturers decided to move to HCFC and HFC gases. However, it was quickly recognized that they contribute massively to global warming. The uncontrolled release of these gases from one fridge can be as harmful as a whole year's exhaust emissions from a family car. While the use of ozone-depleting substances, or ODS, have been drastically cut, large amounts of it still exist in buildings, products, and equipment. These reservoirs of ODS are referred to as ODS banks and must be dealt with before they escape to the atmosphere. Of 1.1 million tonnes of ODS banked in the EU, 0.8 million tonnes was reported to reside in insulation foams trapped in refrigerators and the fabric of buildings. In 2001, laws were introduced to ban ODS, and following that, laws to ban potent global warming gases such as HFCs from products and to prevent their release when recycling. Engineers quickly developed technology to capture these gases from domestic refrigerators, as they fell within the EU directive to divert waste electrical equipment from landfill. This directive, however, didn't apply to many other foam-containing products such as construction panels, meaning manufacturers were not pushed to support further technological developments, and gases continued to escape. As ODS gases were used right up until 2004, it must be assumed that any building constructed before then using foam panels contains ODS, unless testing proves otherwise. This is called the precautionary principle. More recently, there has been a move to non-ODS, but highly flammable hydrocarbon gases, such as the pentane used to reclad Grenfell Towers. This has been referred to as being like dousing the building with 32,000 litres of petrol. Something had to change, and manufacturers are now moving to gases like CO2, which are inert and can be said to be borrowed from the atmosphere. Now, we just need to work together to clean up the legacy. This requires some creative thinking and the use of innovative recycling technologies. During recycling, items larger than a domestic fridge require pre-shredding, and anything containing pentane comes with a risk of fire and explosion. This has led to plant failures across Europe. The solution is to introduce nitrogen throughout a pre-shredding and twin granulating process to maintain and monitor an atmosphere below the explosion limit of pentane. The result is a foam granulate which then passes through a form of thermal decomposition called pyrolysis to generate heat and electrical power. Recovered metals, plastics, and other materials are then sent for processing into new products. eSynergy, technologies that safely preserve our environment.